The energy transition needs many ways to decarbonize power generation and high-temperature industrial systems. Skibo Energy has a unique thermal energy storage design that supports our storage-first solutions. How do we do this? Our thermal energy storage basically creates miniature suns. These suns are fueled by solar system nuclear reactors. The sun delivers diffuse heat around the world. The sun also drives our wind and rain. Vegetation is grown to create biofuels, and in the future, fusion reactors will create heat. Fission nuclear power from the Earth's core can fuel our miniature suns using geothermal heat. Heat will also come from existing and future fission power plants. Why is our technology different from our competitors? First, we can store higher temperatures, plus we can store both hot and cold. Nobody can prevent heat loss, but our design captures the heat to make it useful for lower temperature power cycles and mid-range heat industrial processes. In addition, our solution can be configured to deliver high-pressure heat to drive gas turbines at efficiencies that enable economic solutions. I would like to stress that with Skibo Energy's unique TS features, this can be done today without requiring any technology breakthroughs. We have identified 3 markets that enable the transition from combustion-first to storage-first power generation. First, we can convert existing natural gas base load and peaker plants, which enable the reuse of existing infrastructure and thus speeds up the transition. This technology can also be used to improve the performance of existing and new nuclear power generation plants. Next, our storage-first approach will increase the electricity output from geothermal installations by boosting geothermal heat to higher temperatures. The third market is microgrids. Adding long-duration energy storage to systems in the 1 megawatt or larger will increase their performance along with providing energy security and resiliency. We believe there are many more markets. What are the key features of storage first relative to the transitioning gas plants? Store waste heat. Currently, millions of dollars are being thrown away at power plants. Use excess electricity to boost temperatures. We call this peak electricity. Store heat at temperatures that can drive gas turbines. And in addition, we store cold, which expands our temperature differential and enables other performance improvements. Let's use the existing Tate gas peaker plant in Dayton, Ohio as an example. Note that these numbers are rough estimates and are expressed relative to annual operation. The plant burns about 9 million BTU. This translates to $24 to $48 million depending on the price of gas. This produces about 1 million megawatt hours of electricity, which then can be sold for $40 to $60 million. But this also creates 1.5 million megawatt hours of thermal heat, which is currently thrown away. This means that up to $32 million is wasted every year. Now let's add a storage-first solution that can be cycled 200 times a year. We do need to boost the saved exhaust heat with renewable electricity. That will cost around $15 million. But this doubles the plant output and thus annual revenue. All this for only 465,000 tons of annual CO2 emissions. To put this in perspective, this is a tiny fraction of global annual emissions, but with about 10,000 gas plants globally, it's a huge potential market and the impact can be big. In future phases, we can cool the inputs to the turbines to reduce the amount of gas burned, plus additional PV. Wind, nuclear can be added to the grid because our storage is available to take peak electricity. Paul has decades of experience in thermal energy management and large system development. Harry has large and small business experience. We have spent $3.5 million in development and testing. No one else is tackling the retrofit of existing gas plants, which already have the power blocks, grid connections, and customers. The projects are big with the payoff of adding more renewable energy onto the grid. When demonstrated, this technology will be available for future markets like geothermal and microgrids. With federal policy, Skibo Energy's thermal energy storage and storage-first system designs, we can tackle the tough decarbonization challenges today.